Hello, everyone. Thank you all very much for joining. My name is Brad Stasic. I'm a solutions architect here at AWS, currently based in Sydney. Today, I'm going to spend a little bit of time talking about some of the various tools and services that you can leverage in order to help build engaging mobile apps, both web-based and native. The presentation recording and the slides will be shared within the next week. So if you'd like to share those presentations with your colleagues or revisit the content, you should be able to do that at that time. At Amazon, we really believe that there's never been a better time to build. In the case of mobile apps, they've really gone from being a nice-to-have part of your business to being a core part of how the world sees various brands. And at AWS, the tools we've developed to help you build these apps have really evolved over time, and sometimes it can be a bit difficult to understand specifically where to start. So before I get into specific tool sets at AWS, I wanted to set the scene a little bit. It's probably no surprise that the usage of mobile devices is continuing to grow all around the world. Just to give you one example, over 90% of the adult population in the United States has a cell phone, and over 60% of those are actually smartphones. To give you just a couple more data points around smartphone usage, in 2013, Google's Android market passed 50 billion app downloads. In 2014, Apple's iTunes passed 75 billion downloads. And last year alone, over 197 billion apps were downloaded, resulting in approximately $77 billion in revenue outcome. And we've also passed an inflection point where mobile usage has actually surpassed desktop computers in terms of how people are accessing the broader internet. So all of these factors combined really just go to highlight how prevalent mobile usage is and how your business would be well suited to consider how you build and deliver high quality mobile experiences to your users. So when users are asked what they rate as most important in a mobile experience, the foundational components are of course a must. You have to have an intuitive user experience, some basic personalization options, and the ability for users to share their experience state across all of their different devices. But there's some other additional features that, when they're implemented really well, actually make your app stand out quite significantly. Things like biometric identification in a financial services app, voice control, geolocation, and a number of other different things such as social features to share with their social network. Another trend that we're seeing fairly broadly is that web and mobile experiences really are converging. Certainly native apps can be preferable in some situations, such as if you need the ability to have native feature support on the devices. But having those native apps definitely comes with some challenges, things like vendor lock-in and limited ability to share code across different vendor solutions. Some of the benefits of building native apps can actually be gained from writing cross-platform apps using things like React, such as still having a presence in the vendor's app store. But new features generally have to be supported by the open source community, and this means that they might come a bit later than the native app support. But you do gain the benefits of being able to reuse much of the code across the different platforms. However, lately we're seeing many different developers are actually opting out of having native or cross-platform specific apps and focusing heavily on progressive web apps, using things like AngularJS to really be able to have that single code base, so your users can access your mobile experience on any device and have the exact same experience. Regardless of which one of the paths you take, there's a common set of concerns that you as a developer have that remain pretty consistent. You want an engaging experience for your customers that can be delivered securely, one that's going to scale if your app becomes highly popular, and generally you're looking for a mechanism to monetize your app in some way. So AWS offers a number of different services that you can plug into your app with minimal effort, which really help make it easy to build and maintain your app as well. I'm not going to go into depth on every single one of these services here today, but I did want to highlight that you don't need to be an expert in which one of these services can help for which specific need in your app. That's because we've built a mechanism for you as a developer to actually go in and select distinct application components instead of having to know all of the specific services. And so that's where I'm going to introduce you to AWS Mobile Hub. The goal for Mobile Hub is actually to build apps on AWS with little to no friction for the developer. There's 4 underlying tenets for the Mobile Hub experience. The first one is that we wanted users to have a single integrated console. We didn't want developers ping-ponging all across different consoles for different services, as that can be sometimes a distraction. And so we made an effort to consolidate into this one single integrated experience. The second tenet is we wanted the features in Mobile Hub to really be fairly pre-built for you. We didn't want to just give you the SDKs and different services and have you move on there. We heard developers loud and clear that they want to combine different services into functional features that really power your app experiences. So we focused on pre-packaging things that combine multiple different services and really provide more client implementation beyond just the raw sort of low-level SDK access points. And really as part of that, we didn't want to have developers provisioning those services directly. We wanted to take care of that for you. So we wanted to keep you in that single integrated console I mentioned and take advantage of some of the security best practices that AWS offers. We didn't want you to have to learn the ins and outs of every different component or try to dive into the identity and access management console on your very first visit. So we actually automatically provision these things for you with zero touch. And the fourth tenet is really an auto-generated app. And I think this is really the most important one. We wanted to give you actual working code that works directly with the services that we've provisioned for you immediately. We find that static sample apps can sometimes become quickly outdated, and we wanted you to be able to immediately get started with exactly what you've just provisioned. And so that really means you get a fully functional skeleton app for both iOS, Android, as well as web native apps. And so in just a few minutes, you can actually get started using the various AWS services. So I want to do a really quick demo just to give you a view into the console experience for Mobile Hub. So when you go into the Mobile Hub, you actually see your applications categorized by project as opposed to a set of distinct services. I have one example app here, but we also have a couple different starter kits and tutorials that can get you going with, for example, a Notes app for Android or iOS, or a sample restaurant ordering kit, and even a pet tracker if you'd like to use some of the React or React.js functionality. But I'll highlight this example app that I have here very quickly. You can see that it's configured to be an Android app, at least initially. I've configured a handful of different backend functionalities. Here, I've highlighted the ability to send push notifications and SMS to users. I've enabled a user sign in and sign up functionality. And I've defined that I want to use an API with some cloud logic behind it using services, API Gateway and Lambda, which I'll talk about briefly. So I'll just go into this cloud logic example. Hopefully this is large enough on your screens there you can see. Currently I have 2 different backend methods for my API, an item handler and an update score. I want to show you just how simple this is actually to configure new methods and endpoints. So let's say that I want to add a new method that's just called list scores. Simply just click the plus, add in my method name, choose a few options here, and simply update the API. Behind the scenes, the Mobile Hub interface is actually deploying a new API gateway for our application. It's configuring a Lambda function for that new API, and you can see the update here is now in progress, and it'll complete when it's done. But I'll show you that I can actually directly edit the backend code too. So for this update scores method, I can select to edit it, and it takes me directly into the Lambda management console, where I can see a handful of different detail about my specific configuration, the monitoring of this individual microservice, as well as actually inline editing the function directly. And it's very handy that they provide a handful of different default configurations here that show me how I can build my own method from the data that's being sent through. So that's just a really quick highlight of exactly how simple Mobile Hub is to use. You can see if now I'm ready to actually integrate the logic that I've changed within my application, I can download either the configuration as well as the API modeling and just throw them directly into my app's code structure here. So I'll go back to the path here, but hopefully that just highlights to you that Mobile Hub does really make it simple to get going. It allows you to manage, as I mentioned, a number of different AWS services as a single logical project and know that they're being configured using various best practices, and really to use that as a starting point for your repeatable application deployments. And I mentioned this before, but I just wanted to reiterate that Mobile Hub actually gives you a project output that includes Xcode or Android Studio project with all the code that's ready and configured for your specific resources that you can deploy out to devices immediately and then customize in whichever ways make most sense for your particular use case. So I chatted a bit about Mobile Hub and talked about how it can bring together the various services for your mobile app. And I want to dig into some of the details about what those distinct services actually are, starting with the ones that are going to make up the mobile backend for your app. There's a number of different architectural approaches you can take when you're building a web-based application for mobile users. And some of these you're probably fairly familiar with, things like a 3-tier web style backend, more service-oriented architectures, etc. But broadly speaking, we're seeing a significant shift towards serverless microservices. And just so that we're all on the same page, I want to break down what I mean when I say serverless microservices. So a microservice is really just an atomic, self-contained unit of code that maps to specific business functions that you can easily develop, manage, and share. So a distinct business function might be something like encrypting a document, or transcoding content, sending an email, or maybe creating a new account in something like Salesforce. And when we talk about serverless, what we really mean is that we want you to focus on building your individual services and not worry about the infrastructure on which they're running. And this, again, is going to allow you really to kind of develop, run, and scale your apps and microservices without having to provision or manage any of those servers. So as a managed service, you don't actually have to worry about the infrastructure. Some of the foundational concepts of serverless microservices are really that, generally speaking, they're accessible via RESTful API. They tend to be easy to develop, deploy, and manage, and have a consumption-based pay model. By default, they should support user authentication and authorization, things like OAuth servers or social identity providers. And from a security and compliance perspective, they should provide metering of your APIs, execution of their microservices under specific policies and context, and give you detailed logging and monitoring. And finally, it's probably worth noting that you should also have the ability to integrate with various resources and other APIs that might be on premise if you already have a computing footprint somewhere. So the 3 primary services I want to highlight to start with form really the basis for building serverless microservices on AWS. You, of course, can use the technologies that you like, but these 3 bring specific benefits that I'll highlight here today. So here's a visual diagram, just sort of a high-level architectural workflow of where the distinct pieces will live. Cognito is a user identity management service. Lambda functions there on the right-hand side are the core logic for your application. An API gateway provides the interface to actually organize those Lambda functions into a comprehensive application. So I'll dig into each of these a little bit right now to give you a flavor for what they are. Starting with Lambda. So AWS Lambda lets you run code, again, without provisioning or managing servers. And you only pay for the compute time that you actually consume. So only while your distinct logic is executing is there actually a billing component. So if your code is not running, there is no charge. You can run Lambda code for virtually any type of application or backend service with zero administration. You quite literally just upload your code, and Lambda takes care of everything required to run, to scale your code with high availability. And you can actually set up your code to automatically trigger from other AWS services, or you can call it directly through your web and mobile app. And I'll talk a little bit more about that on our next slide here. So in the case of a mobile application, you really probably want synchronous invocation. And by that I mean when someone sends a request through your API, they're probably expecting a response back immediately without waiting for it. And that's typically what we want, and we can use API Gateway to interact with our Lambda functions in that way. But it's also worth pointing out that Lambda can be executed a number of different ways. So for example, in response to an event, such as when a new file is stored in our simple storage service, or when a publish and subscribe type of message notification is triggered. So although today we're only going to really focus on the API Gateway mechanism to trigger our Lambda functions for an API, note that Lambda is very flexible and gives you a lot of options. The next service I want to highlight here is API Gateway. As the name implies, Amazon API Gateway is a fully managed service that makes it easy to create, publish, maintain, monitor, as well as secure your APIs really at any scale. And so some of the things that it's going to actually handle on your behalf are things like processing of concurrent API calls, traffic management, making sure your users are authorized and have appropriate access control in place, keeping an eye on the monitoring of the calls, and doing things like version management. Version management in API Gateway is extremely powerful actually, because it really lets you simultaneously run multiple versions of the same API so that you can really quickly iterate and test and release new versions of an API. Although you can use other backends with API Gateway, it does have tight integration with Lambda. And so it allows you to create completely serverless RESTful APIs by using Lambda. Once your API is actually deployed, the API Gateway provides you with a dashboard to monitor the calls to your services, to see performance metrics and information about data latency, as well as error rates. And if you're already using something like OAuth tokens or any other authorization mechanism today, you can actually use what is known in API Gateway as a custom authorizer using custom Lambda code to help you verify incoming requests. And so really this just allows you to verify signed API calls on your behalf using some of the same technology that AWS uses for its own APIs. So here's a bit of a visual example of what an authorization flow looks like to authorize API access to API Gateway. I didn't want to go into the specifics here too much today, but I wanted to use it as a little bit of a segue into the next section that I want to highlight here: authentication, authorization, and access control. It probably goes without saying, but user identity is pretty critical for your applications for a number of different reasons. Certainly, you want to make sure that only authorized users are using your system resources. Storing your user data in a way that protects your customers' privacy is also important, not only to earn and retain your users' trust, but also to ensure the integrity of that data. But I'm sure you also want to understand and know who your users are and how they're actually engaging with your application. So we understand why user identity is important in apps, but developing actual auth infrastructure is difficult. Most organizations aren't experts in writing identity systems and usually don't want to be either. They typically want to focus on the important work of building the functionality in their app and improving their user experience. And that really brings us to the last of the three services I initially mentioned here, which is Amazon Cognito. So Cognito lets you add user sign-up, sign-in, and access control to your web and mobile apps quickly and easily. I kind of showed you what the interface would look like to enable it very briefly in the Mobile Hub. But it also supports sign-in with different social identity providers. So if you want users to log in with a Facebook account or a Google or an Amazon account, for example, it supports that as well. And it also supports existing enterprise identity providers. So if you're writing an application for your business users, your internal business users, for example, you can use something like your ADFS server via SAML 2.0 to authenticate users using Cognito as well. Now, if you don't already have an identity provider today, and maybe you choose not to use a social identity provider like a Facebook or a Google, Cognito has a functionality called user pools. And really what this means is that it will be able to deliver to you serverless authentication and user management that scales up to hundreds of millions of users and includes a bunch of really interesting baked-in support to do things like verifying your users via phone and email verification support, offer MFA, etc. Without, again, going into kind of every feature, there's a couple that I really wanted to call out that Cognito provides. One of them is the ability to define custom attributes for your users. So there might be something specific in your app that you want to be a part of this user account itself, as opposed to being contained farther in your data domain. So it allows you to do that. It also allows you to enforce password complexity requirements and do a bunch of standard administrative features that you'd probably expect in a system like this, things like resetting passwords and deleting user accounts. And the last feature of Cognito that I'll identify here is if you do have an existing user base, you can actually import it into Cognito. So this makes it painless to import your existing user base into that Cognito system and hand off some of that heavy lifting of dealing with storing passwords securely, dealing with password resets, etc. So now that we have a little bit of context on the various services, I'll put this diagram back up just for a minute to highlight that once we've verified a user's identity with Cognito there at the top, the calls to API Gateway can then be configured to either pass back to our Lambda functions or potentially reject user access based on different policies we have in place based on the user's criteria. So we spent a bit of time talking about the backend functionality of your app, but I want to focus a little bit now on one tool that can really help with the user engagement and analytics side. It's worth noting that AWS does have a large number of services when it comes to analytics use cases, anything from typical relational databases to managed Hadoop environments, all the way through to fully petabyte scale data warehouses. But the tool that I'll focus on today in the terms of a mobile analytics platform is called Amazon Pinpoint. So Pinpoint helps you engage with your customers by doing things like sending push notifications, sending targeted messages such as promotional alerts and customer retention campaigns, and it supports things like direct messages for things like order verifications, password resets, etc. It's worth noting that you can actually integrate Pinpoint directly into your apps to capture usage data to help really better understand how the customers are interacting inside of your app. And it also can track the number of ways that your customers responded to the messages you sent. So for example, you can show the number of messages that were delivered successfully, opened by your individual users, or clicked. Pinpoint has a number of additional capabilities, things like scheduling or recurring campaigns, which also, of course, include the campaign analytics components. You can do A/B testing, which is built into the service to actually test out the success of new campaigns. And you can also define times to send messages and define message caps based on your particular segmenting of your user base. And you can also segment on things like frequency of use, the recency of use, as well as any of those custom attributes that we discussed briefly before. So there's a couple different ways you can actually interact with Pinpoint itself. You can access programmatically directly through a Pinpoint API, and that's a really common use case. Or let's say that you have a group of marketing professionals internally that are more comfortable with perhaps using the actual console experience. So both of those are perfectly fine. Behind the scenes, Pinpoint actually uses two different services, both the Amazon Simple Notification Service to do the sending of the messages and Amazon Mobile Analytics to gather the analytics data. But you really don't have to worry about the specific implementation details, as Pinpoint actually abstracts that for you and provides its own interface. But the reason that I did bring it up is that because Pinpoint uses Simple Notification Service to deliver the messages, you get a number of additional benefits. So one of my favorites is actually some of these really specific local restrictions with message sending that we've solved. There's a couple examples here, but I'll call out one. There's a carrier in India where promo messages are actually prohibited between 9 p.m. and 9 a.m. And so as part of the service, we've actually accounted for that. And so messages that are to be sent to this particular carrier are actually buffered until that time window completes, and then we'll continue to send messages. So you don't actually have to worry about the logic of solving all these individual local restrictions on your own, as the part of the service will actually handle that on your behalf. So we've talked primarily about a RESTful API backend when we're talking about API gateway with Lambda, for example. But there's another approach that's been gaining popularity, and that is GraphQL. So AWS AppSync is a fully managed serverless GraphQL service to do real-time data queries, synchronization, and other sort of offline programming features. For anyone that's not familiar, I'll just highlight what GraphQL is very, very briefly. So GraphQL is a responsive data query language, and it really operates at the application layer. So you can use GraphQL to build a responsive API for use in your client applications. It includes things like a type system to define schemas, and those actually serve as specifications to define how the operation should be performed on the data. Again, without getting too technical, just know that if you are interested, you can use AWS AppSync to operate your managed GraphQL environment. And it does a couple interesting things. So it allows you to update the data in the web and mobile applications in real time, and updates data for offline users as soon as they reconnect. So some of that logic you don't actually have to rebuild. And that just really makes it easy to build sort of collaborative mobile and web apps that provide a better user experience for your end users for those sort of collaborative apps. From a technical perspective, the really high level differences here are GraphQL is defined by schema. Clients actually send queries directly, and the server just orchestrates the data over whichever transport you prefer. And that could be HTTP, MQTT, or WebSockets. And how that's different from the actual API gateway model that we talked about originally. You can see a visual representation of that here. In this model, you actually have resources that are defined by endpoints which you configure that the client calls. And then it's up to the logic in that endpoint to actually determine what query should be executed. And generally speaking, that's only going to allow you to use HTTP as a transport. This is a fairly tried and true mechanism. This is the most common things you'll see out there. But if you do want to learn any more about GraphQL in your application, you can actually visit the GraphQL website here to learn more. And again, these slides will all be available in approximately 1 week. So we've talked a bit about getting this skeleton app running using AWS Mobile Hub. We've made some API choices. Maybe we've gone with the RESTful API, or maybe we choose to go with the GraphQL model. But the last thing I really want to talk about, without having to worry about which specific backend model you've chose, is actually to cover testing your application. So AWS Device Farm is an app testing service that lets you test and interact with your Android, iOS, and web apps on many different devices all at once. Or alternatively, you can actually reproduce the issues on a single device in real time through your web browser. And so you can do things like view video, screenshots, logs, performance data to actually try and pinpoint and fix issues to increase your app quality before shipping your app without having to own a ton of different devices. And just to reiterate, so testing can actually be against a native app, a hybrid app, or just a completely web-based application. For any of the automated testing you might want to do, we have a built-in test suite as part of AWS Device Farm that doesn't require any scripting knowledge. Or you can use open source test frameworks you might already be using today, things like Appium, Calabash, Espresso, to simulate real world environments. And you can also actually fine tune the environments that these devices live in by configuring which location you want them to be identified as, which language the devices are running, things like simulating poor network connection, and even things like installing prerequisite apps to simulate existing customer conditions. Because the testing can actually be automated, you can integrate this directly with your development workflow, which really just helps you automate that whole process. But as I mentioned before, you can use the remote access functionality within Device Farm to do things like gesture, swipe, and interact with devices directly in real time, straight from your browser. So all you really have to do is select different device attributes that you want to use, such as the make, model, and OS version, and then test out your app in real time straight away. So Device Farm has both pay-as-you-go pricing as well as the option for doing unlimited testing for a fixed price. So if your primary business is actually building mobile apps, that could be really compelling. So as you can see, we've built various tools to fit in with most of the typical mobile development life cycles. Hopefully this session has been a bit informative and helped you consider some of the various ways that the AWS platform might actually be able to help you with your app building needs. And although we did cover a fair bit today, we've really only had some time to scratch the surface. So please feel free to check out the AWS mobile landing page for more details on this service and any others that we haven't had time to cover. That's really the end of my prepared content for today, but we have some time for open question and answer. So please feel free to submit questions and I'll do my best to answer them. And please do stick around and leave feedback on this webinar as well as any recommendations for the next webinar. Again, the recorded presentation and slides will be shared next week. So if you'd like to share this prezo with anyone or revisit the content, you will be able to do that. There are actually 3 poll questions that should appear on your screen. So if you're able to fill those out for us, that would be extremely helpful. And we really appreciate your time today. And thank you very much. Open to any questions. Okay, so we have a question here that is AWS Device Farm available within the Sydney region? The Device Farm today operates in what we call a global capacity. So the specific location of the devices does not get identified specifically. It's just operated as a global service. I believe that they're operated out of Oregon primarily today, but the Device Farm website would have a bit more specific information on that. Okay, we have a question here. Can you deploy a native Apple app from AWS? So using something like the AWS Device Farm, you can certainly test your iOS applications inside of that framework. The Mobile Hub also has pre-baked code for iOS using Swift and Objective-C. So we certainly support it in both of those realms. If there's a more specific detail you're looking for, I'm happy to answer that, but at a high level, you certainly can do iOS app building on AWS. So there's a question, can we push apps to the Apple App Store? Unfortunately, I do mostly Android side, so I don't know the exact answer to that. I am not 100% certain if there's any restrictions on the terms of service on the Apple side that would restrict that from happening, but you can certainly check what the specific details for iOS app deployments are, and that should be able to give you some information. I think there might be an API key that you have to embed somewhere, and so that would be the only restriction that I'm specifically aware of, but unfortunately that's not my specific area of expertise. All right, well, as I mentioned before, the content of the slides as well as the recorded presentation will be available after the meeting here in approximately 1 week. Other than that, I don't see any additional questions, so we will wrap it up right there. Please feel free to visit the mobile landing page there for all the information that I've presented here, as well as quite a bit more. So thank you again for your time today, and I'll see you soon.